Yeah, Michelle, you have to just be patient for a couple minutes. There might be a few stragglers that comes in, but we'll get started, eh? A few stragglers might come in from the hallway. They just made the announcement a couple minutes ago, but we're a couple minutes behind schedule, so we're going to get started. We saw the EcoFlow residential sewage treatment system this morning. I think that was very well received. Lots of good questions from the audience. This afternoon session with Premier Tech Aqua focuses on the decentralized and communal wastewater products that they have to offer. It's a new line for the Shaw Group, and we're very excited to be a partner with Premier Tech, and I think they have a lot of technology and sophistication to offer, and I'm sure that this group will learn a lot. The presenter for us this afternoon is Michel Lemieux. He's the biologist from the University of Quebec in Rimouski, and he joined Premier Tech Aqua in 1996 and has occupied different functions in the sales department with Premier Tech Aqua. He's now the market development director. So I'll welcome Michel to the stage now, and we'll get started. Michel, thank you.
Thank you. Can you hear me well? Okay, thank you, Ryan. So since Daniel presented the Premier Tech already this morning, I will skip this part of the presentation and start briefly, just to mention to you that we have three groups of activities. And here you see we have Premier Tech Aqua Purflow in France. We have Premier Tech Aqua in North America. Just to tell you also that we have a partner in India, Premier Tech Kronos. They are based in New Delhi, India, and we do quite a few projects in Asia and especially in India. Back to the Environment Technology Group. We work in smaller flow with the EcoFlow biofilter. Just to mention to you that if there is any commercial project, small project, we can use 2 or more EcoFlow, put the EcoFlow in cluster to handle small flow, let's say from 2 to 15 cubic meter per day. We have a more commercial system. I will discuss about that today, and we have municipal and industrial system with the SBR, that is for sequencing batch reactor. The first project I will talk to you about is the RotoFix. If you have to deal with a domestic type of wastewater, if the requirement for effluent is not too high in the 2020 range in BUD5 suspended solid, the RotoFix is a nice unit to work with. It is RotoFix. It's a RBC. That's for rotational biological compactor. It's also known as a biodisc. We developed the RotoFix based on the biodisc technology, but we wanted to improve the biodisc. There was some problems associated with biodisc in the past. One of the problems, the accumulation of biomass in between the disc. You see, with our product, the media is kind of parallel to the main shaft. When biodisc, typically it is perpendicular. In this case, in the past, there was accumulation of biomass in between the disc, and eventually there was mechanical problems associated with that. With the RotoFix, because we have the media installed like that, the biomass that will accumulate on the support will be washed out, and so there be no accumulation of biomass and no mechanical problem associated with that. So what you see, it's a very simple way to drive the drum inside the wastewater. It's an electric motor, gearbox, pulley, and a strap, basically. And it's all installed in a drum, and the drum is installed in the wastewater tank. You see here the flow diagram. We have a septic tank, and then we have equalization tank, because the wastewater is not generated evenly during the day, so there is peak flow during the morning and evening. So we typically have EQ tank to pump the wastewater from to the wastewater treatment system. Here we use a agitator to mix the solid together with the liquid before we go to the treatment. And then after we have the treatment. Let's see. This is the treatment part here. And over there is a decanter. And let's check if it starts. Okay. So you have your septic tank. The solid will accumulate in the bottom of the tank. The fat and grease will stay on the surface. Here we have a effluent filter into the septic tank. So we feed the EQ tank, and the pump will pump to the treatment system. And in the rotofix, you have rotation of the drum into wastewater. When the media goes into the water, there is air in between the spaces into the media, so the air will blow out at every extremity of the media, and you will have aeration. And when the drum goes out of the water will flow down, into the system. That's a very economical way and efficient way to have a good aeration and agitation into wastewater. The bacteria, they will grow on the media. They have food there, they have water, aeration, so that's a good condition for the bacteria to grow and to remove the contaminants from the wastewater. After that, the water will go into the decanter. This is a device that is designed to separate the suspended solid from the wastewater. So the way it is designed, the bottom of the tank has a kind of a conical shape, and the sludge will accumulate on the bottom. Here there is kind of two lines. One line is a compressed air line that will push compressed air into a Y, and that's be kind of a airlift system, meaning that when you introduce air into the water, the density will be less, and this will pull the sludge together with the water upstream, and eventually this will go to whether the septic tank or to a sludge tank. In the decanter, we also want to remove floating material that be as calm on the surface, because sometimes gas will be generated and some of the solid will float on the surface. And we have a valve, and we will open, and the floating material will go at the same place as the sludges. So the advantage of the Rotofix, we have a good quality price ratio, low energy, very, very low energy motor to drive the Rotofix. They are 0.5 or 3/4 of a horsepower motor. It's very simple, flexible, easy to operate. If there is a problem, and eventually, some of the motor will have to be replaced, but it's very easily accessible for the operator. And when we mention aesthetic, it's because, and we will see that's because we can install the Rotofix in a small building that can be integrated to the local environment. Some case study, Mont Saint-Sacrement School, 35 bedroom. The project was designed for around 70 cubic meter per day. It was started up in 2001. It was installed to replace a recirculating sand filter. And now what you see here, it's the small building. All the wastewater treatment is installed in the building. It's just beside the gymnasium for the school, and there is no other problem associated with the installation. Saint-Michel de Napierville, it's a township about 20-minute drive south of Montreal. That's a new house development, about 100 home, 125 in fact. And the developer wanted to start doing on-site system, but the soil condition was so bad as it did not work. It was a lot of clay soil, and eventually the developer contacted us. And what we did install kind of alternative system, meaning that each house on this project, they have their own septic tank. So we can run a smaller diameter pipe than the conventional sewer system, and we don't have to go as deep in ground because we can use a 1% slope rather than 2% slope. And we'll see it better on another slide, but here that's the small building where it is installed. And this developer, he did the second phase of the project, and he installed that in a different type of building because the new development has a bigger home. Just to show you, this is the wastewater treatment plant. That's the home together. Now it's a nice development that is all paved, and it has, its operation since 2006. And just back, I think I wanted to mention, just to mention to you that the operation cost of the system. Every home over there, they pay like a local tax, and they pay $160 per year. This amount cover pumping of the septic tank every 2 years, pumping of the sludge tank at the treatment facility, as well as energy and chemical, because in this case they have phosphorus removal, and they use aluminum sulfate to precipitate the phosphorus into the last rotofix. Stanbridge East, 85 home, a small township. This is a picture of inside the treatment plant, 85 cubic meter per day. There they have phosphorus removal and disinfection. We use the same type of UV lamp that Danielle showed this morning, the Hallett lamp. And just to show you, we can arrange the plant so it looks okay. In this case, it has a kind of a sugar shack look. Other product that we have in our product line, that's SegFlow. It's a recirculating biotower. If the project involve higher strength wastewater, like a restaurant, like grocery store, this kind of wastewater, and if the flow is in the 5 to 100 cubic meter per day range, the SegFlow is a nice technology to use. It can reduce very much the strength of the wastewater, and that's most of the time why we use this technology. Just as an example here, this is a treatment unit that was installed in Notre-Dame-du-Portage. That's just not far from our head office in Rivière-du-Loup, about 2-hour drive east of Quebec City. That's a inn, and what we see here, it's the SegFlow during the construction phase. How do that work? Again, we have the septic tank, EQ tank, just like with the Rotofix, but rather than use something that is moving as the media, with the SegFlow, we have a similar media as the Rotofix, but it's pieces of about 3 inches diameter and 3 inches long that is installed in bulk into the SegFlow tower. And the treatment will happen in the tower. Most of the time we will use a 2-stage tower. When we need extra capacity, we can use some system in parallel to increase the capacity. And at the end of the system, typically we have a septic tank to remove suspended solid. Just a second. Okay. And again, we have the septic tank. We have the EQ tank that will feed the SegFlow tower, and then after in the SegFlow, we feed the system. There is one pump here that is a recirculating pump, and there is a rotating arm, just like in the dishwashing machine, that will spread the water evenly. I'll wait for the next step. So water goes up, rotating, distribution, treatment into the media, and after that, there be sludge produced, and the sludge is pumped to a sludge tank or to the septic tank. And that's key in this process, in all the process, to remove the sludge, because any biological treatment system produce sludge. There is bacteria, the bacteria, they die, they produce a biological sludge. It has to be removed, because if it's not removed, it will accumulate and eventually will clog a filter. After you see the sludge coming back to the septic tank. After the sag flow, we have a sedimentation tank, a pump. We don't always have this portion. This is when we need the polishing. In this case, it's polishing into what we call EcoFlex textile peat filter. And again, we have pump that will spread the water evenly on the surface of the peat textile filter, and this will produce a very high quality effluent. Just to mention that last summer, that's this type of system that was installed at Atlantic Superstore in Tantanan. So seg flow, high performance, very small footprint, flexible. We can deal with domestic type of wastewater and as well as high strength wastewater. Very easy to operate. Basically, that's a few pumps with it's all controlled by a control panel and a PLC. Very simple operation. Economical again. Pumps do not spend a lot of energy, and it's a very reliable system. There is kind of two options. It could be assembled at the precaster location, like these pieces. Typically, these pieces are casted at the precaster manufacturing facility. The media is installed into the tank, and it is shipped together with the tank, and it is assembled on the site. The other option, and that's an option that we do a lot of projects in the Caribbean, and over there we don't ship the concrete over there, but they make the concrete locally, and we ship a kit of the seg flow over there. Can you hear me over there? Yes? Because I think this is not working anymore. But okay, knowing that it's not working, I make sure that you can understand me. So the two options to make the pieces at the precaster location, or to have the concrete cast in place. In North America, in most cases, we will deal with precaster. And there is a kind of a two type of tower, whether it is a square tower, or we can use a round tower. The project at Tantanan has been done with a circular tower. And it's depending, on the availability of the product as well as, for some reason, sometimes it's easier to deal with a square tower, and some other time, circular are okay. And there is different capacity depending if it's a square tower and a circular one. Just to mention that the higher flow that we will handle with a single tower will be around 45 cubic meter per day. Other picture of the installation at Notre-Dame du Portage. You can see that sometimes it's big tanks, big piece of concrete, and it's installed quite fast. Typically, we have the crane on the site and a good planning, for delivery by truck. And typically, we do everything the same. We put all the pieces together the same day. What you see over here, that's EcoFlex unit. Other case we did, that's in Martinique. That's small, very small footprint installation. Typically, there is a one big septic tank or EQ tank or both, and then that's the tower, that's the control panel. and that's it. And it's very easy to integrate that in the landscaping. Other technology that we are just bringing into the market now, even though we work to test the technology for more than 3 years now, it's the membrane bioreactor. So membrane bioreactor, typically we will use it wherever there is a very sensitive area because it can produce very high level of treatment. Not you, not me. Anyway, so it can produce a very high level of treatment, and if there is a very high requirement in BOD5, suspended solid, phosphorus, total nitrogen, disinfection, membrane technology is a very good way to go. Membrane is well known in the past, mostly for drinking water. It has been used for many years, and now it is used in wastewater industry about for 10 years now. Exactly for the sensitive area reason. What is an MBR? MBR is for membrane bioreactor. The membrane bioreactor is activated sludge technology. So what you see here in the picture is an activated sludge. The membrane cartridges are installed into the activated sludge tank. And rather than go into a clarifier after the activated sludge, we run the water through the membrane to remove all the solids. And we see a picture here of the membrane would be those white part over here. In the middle, there'd be some kind of backing in between the pieces of a membrane. This being the wastewater, and what you see, it's kind of a bubble of air that will be used to clean, to score the membrane, to keep the membrane clean. So again, the diagram of the process, septic tank, again, with EQ tank. Here you have the MBR, membrane bioreactor. The first part will be like activated sludge. You have a fine bubble diffuser. That's where, we have the air for the activated sludge process to take place. And I try to run this right. Okay, you see again the septic tank, dosing tank, and we feed here the we feed the MBR, so water will go there, aeration. Eventually, this pump will stop. There is different configuration, but this is a small compact configuration. So the membrane can take so much water, so every overflow will go back into the reactor, and this is connected to a pump, and the pump, it's a positive displacement pump, so it can go one way or the other. So it is normally used under a vacuum condition to pump the filtrate out of the membrane, but we have a sequence where we can reverse the pump, and then we can do a backwash on the membrane to keep the membrane clean. Also, in addition, we can use a chemical to have a chemical washing over the membrane. That's done once in a while, typically once a month, where we can use chlorine and or citric acid to clean the membrane. The chlorine will be used to remove biological material, when the citric acid will be used more like to remove calcium that can clog the membrane. Just if you can see, that's the flow of treated water outside the membrane. That be a membrane, that be the scouring process, that will keep the membrane clean. And that's what when we do the backwash of the water. You still can hear me? Okay. So that's an automatic process, that will be keep that clean. Okay, the MBR, it's a very good technology. We use flat sheet membrane, and there is advantages of flat sheet membranes as compared with hollow fibrous membrane. The flat sheet membrane are very robust, and they can be cleaned well, and they don't require too many manual cleaning. They are not sensitive to air and fibers. That's something with hollow fibers. Those of you who know hollow fibers, they like macaroni. They float in water, and the fibers will stick on it. And the flat are more robust than the hollow fibers. And with the membrane, we can meet very high quality effluent, do phosphorus removal to, typically we can go to 0.1 ppm in phosphorus. We can do nitrogen removal, and typically we meet California requirement for water reuse. Some example, these are example from our European partner from Germany, Lodge in Mountains, over there they have to air flight the equipment. Golf course and small community or municipality are also some type of project that we can do with membrane technology. This is the last technology that I will present to you. That's a technology that we know very well at Premier Tech. Premier Tech acquired eco-process and equipment in the year 2000, and they had more than 20-year experience dealing with sequencing batch reactor for both municipal and industrial wastewater. So with the SBR, we can also reach high level of treatment. We can do nitrogen removal, phosphorus removal, disinfection. All those are options that can be used with SBR. What you see over here, we're talking about typically bigger volume of wastewater. This is an SBR in the aeration mode. What you see over here is what we call the decanter. In this case, it's floating on the surface of the wastewater. This was a system that was shut down. What you see over here, it's all the fine bubble diffuser. That's a lot of aeration that is needed with these equipment. Just briefly to mention to you that we have all the different tools to do simulation or model of the system, because we have to deal with biological. That's a biological system. We use BioWin as a tool to size our system, and we have to work also on hydraulic on those systems. We typically, with SBR, we have a SCADA system, meaning that the PLC is connected with computer, where we can have acquisition of a lot of data, and we can do reporting. We can do a lot of things with that. Just to mention that very often there is a lot of, we can add a lot of equipment like dissolved oxygen sensor, suspended solid sensor, and the information go back to the PLC, and we can adjust our sequences accordingly. There is different approach for SBR, and depending on the type of the wastewater and the quality of effluent that we need. And I show you two different approaches. One being gradual fill, meaning that we will fill the reactor. That's a big, typically it's a big concrete tank, even though it could be a steel tank. We feed it, we aerated it. There is a sludge removal from the system. And eventually we stop aeration and the water will clarify. And it clarifies from the top to the bottom. So this device is also a very important device. We call that swing canter. The swing canter has kind of two pipe system. The top pipe is a float. This is like an airplane float that floats on the surface of the water. So And the clear water, when we stop aeration, it's always just below the surface. That's why, you know, the suction pipe is always well located in the SBR. It's simpler than the more conventional mechanical decanter. It's all controlled by a valve over here. So this is a batch system. Typically, we will do 4 to 6 batches per day, depending on the characteristic of the project. And with this, we can produce effluent quality at less than 10 and 10 in BOD, 5 in suspended solid. And typically, the type 2 system, we will use at least 2 SBR in parallel. So having 2 SBR, we switch from one to the other one. So there is always one system that is feeding. And also having two SBR, whenever it's time to do maintenance on the SBR, we can bypass the flow and use one to process and do the maintenance on the other one. Type 3 system, we use that mostly like in China for big municipal plant, and where they don't need as good quality effluent. We constantly fill the system here, but we have intermittent discharge. So it's always feeding over here. But we have a baffle wall to avoid any bypassing of untreated water directly into the main reactor zone. And again, we have aeration into the system, the floating decanter that floats at the surface, and the cycle that is controlled by the PLC before we will open the valve and have the treated water to go at the discharge. Typically, we're talking about big flows, 10,000 cubic meter per day. We have a system that run right now in China at up to 60,000 cubic meter per day. So we can handle big flow with this type of a system. Just to mention to you that here in Nova Scotia, in North Preston, there is a SBR that's our SBR that is installed over there. We have a process engineer. We are based in Lachenay, and you can always get in touch with us. We give a good support to a local engineer that will design a SBR project with our technology. So our equipment include floating decanter, air compressor, the sensors, SCADA system, remote technical support. Most of this type of equipment, we will strongly suggest to have telemetry on it. So whether an internet connection, or now we can use a phone connection or cellular mobile phone connection to be able to get connected to the control panel, and we can give support, you know, from far away. We are regularly in contact with our partners in Asia or overseas. We also have package plans that are available for smaller projects, for worker camps, for example. We have a package plan available. So we have a good track record. The system are much flexible. They are able to deal with big fluctuations in flows. For example, if there is high flows during a rainy season or at spring, you know, the system is able to deal with that. And we have a very long-term expertise and service and support with this technology. Some case study. That's a SBR plant in L'Orignal. It's not far from, it's just on the Ontario side across the Ottawa River. It's a picture inside. It's in this case, it's inside the building. 1,200 cubic meter per day. The influent BOD5 is at a bit more than 100, and the outlet is, we need to meet 15, and most of the time we are more like at 5 and 5 in BOD5 and suspended solid. There we have 2 reactors in parallel. This is a picture of the portable or mobile equipment. We typically use a big stainless steel tank, in which tank Some of the tanks are used as a septic tank, and some are used as a reactor for the SBR. So it's all, it can go on the road, it's all on the skids. It can be installed in a worker camp site, and when the camper camp, dismantled, they can take the equipment and go to another site. For example, right now, we have equipment that are installed at La Rivière-Romaine. That's a hydro project in Quebec. They took the equipment from Péribonca, another project, and they move it to La Romaine. And after 10 years, they will have to leave the site in the right condition, so they can just remove the equipment and take it in some other place. So that's just an overview of the different technology that we have. As you can see, there is different ways to treat wastewater. What I want you to keep in mind is that here in Nova Scotia, Shaw is our partner, and you can get in touch directly with us or with Shaw for any project that involves, small flow, medium flow, even large flow. Do you have any questions? Yes? Okay, I would say that others, when you deal with wastewater, others has to be a concern. And quite frankly, when you have a primary treatment or you have a septic tank, it's important that you have the right, let's say, ventilation or odor control to control that. But when you are in the treatment part, like let's say that could be whether the rotofix or a safe flow, when you are in good aerated condition, there is no odor problem. Typically, odor will not come from the treatment system part. It will more come from septic tank or EQ tank. And it's important that when you design the system that you take that into account and that you have the right, let's say, odor control equipment. There is stuff on the market to deal with that. But for example, you saw the picture of the rotofix near the home over there. There is no problem. But in this specific case, there is small odor control equipment just to deal with that. And over there is no septic tank on the side because they have their own individual septic tank, but there is a sludge tank. A sludge tank, there is a little ventilation, got to go through a charcoal filter to take care of the odor problem. But that's always a concern. Yes? Okay, that's a good point, and I would say that SBR has the reputation to be a complicated technology. Now with the PLC and with the dissolved oxygen, sensors, all those things, the system is very much automated now. Quite frankly, and I meet myself operators of treatment system in Canada and overseas, and the comment that comes is they run by themselves. However, it's important that you have let's say, a qualified or competent person that is able to go for follow-up and troubleshooting, because there may be at some point some problem that will come. But typically, like the project that we do with Hydro-Québec, for example, there is a plumber or someone that has some notion of mechanics on the site. That is the resource person over there, and they can be in communication with us, and they don't need to be, let's say, that much of an expert to deal with. It's more user-friendly than it used to be. Any more? So thank you very much. Oops, over there. Correct. Yes. Here in Nova Scotia, that's a requirement from the Department of Environment, and it's based on on flow, if I'm right, eh? After, yes, requires an operator with any kind of technology. Even a recirculating sand filter requires an operator. That's correct. That's my understanding. So it's not any. It has to be licensed here. That's my understanding, Ken. That's my understanding. Is that correct? License.
Well, I don't think it needs to be a licensed operator on site full time.
Oh, no. I think he has to go once a month to pick up a sample and to do a quarterly report. It's not, yes, you're right, that's not someone on the site all the time. It's just something that is responsible for it. And something that typically, if there is any alarm, and all those bigger systems, they have an alarm, that if there is something that goes wrong, there is an alarm that is generated, and that's something that will be able to answer those alarms whenever they come. Anything else? So thank you very much for your attention.
So I'm going to introduce quickly Dan Teal, PNG. We got into the stone straw business about 5 years ago, and since that time we've sold about 10,000 square feet of design-build retaining wall systems. So I'm going to introduce